Every feed starts as one query. Find everyone this person follows. Find the recent posts by those people. Sort by time. Take the first 50. It is correct. It is one statement. And it is fast enough that nobody thinks about it for the first 2 years. Then it is not fast, and the strange part is that no index makes it fast again. So let's work out why that query has a ceiling built into its shape, and what a feed actually is once you stop treating it as a question you ask the database. That first design has a name: fan out on read. Nothing is prepared in advance, and the work happens when someone opens the app. Its virtues are real. Storage is minimal because a post exists once. Changes appear instantly because there is nothing cached to invalidate. And a user who never logs in costs nothing. The problem is who pays and when. The cost of the query scales with how many accounts the viewer follows. And it is paid by a person who is currently staring at a loading spinner. Follow 2,000 accounts and the database gathers candidates from 2,000 sources, sorts them, and discards almost all of them to return 50. Now multiply that by everyone opening the app at 8 in the morning. Every one of those reads is doing the same expensive gather, mostly over the same posts, and none of them can help each other. So move the work to the moment there is time to spare. When someone posts, look up their followers and append a reference to that post into each follower's own feed list, stored ready to serve. That is fan out on write. Reading is now trivial. Fetch one list in order already assembled, which is a single sequential read that stays roughly constant no matter how many accounts the viewer follows. You have traded a slow read for a slow write and a lot of duplicated references. And for a product where reads vastly outnumber writes, that is a good trade. Notice what has actually happened here, because it is bigger than a catching trick. There are now two representations of the same information: the posts as authored and the feeds as consumed. They have different shapes, different indexes, and different lifetimes, and neither is derived on demand from the other. The write model and the read model have separated. Fan out on write breaks in one specific place, and it is the place everybody hits. Most accounts have a modest following, and writing a few hundred references is nothing. But a handful of accounts have millions of followers, and one post from one of them becomes millions of writes, arriving as a burst triggered by a single person tapping a button. Worse, a large share of those feeds belong to people who will not open the app today, so you did the work for nothing. The answer is not to pick one strategy, but to split by the shape of the account. Fan out on write for ordinary accounts and leave the very large ones alone. When a viewer asks for their feed, you read their prepared list and separately fetch recent posts from the few huge accounts they follow. Then merge the two at read time. The merge is small and bounded because nobody follows thousands of celebrities, and the expensive case never happens. One more layer, because real feeds are not chronological. Ranking needs signals, and signals are expensive, so you never rank the whole corpus. You use everything above to produce a candidate set of a few hundred items, and only then score those, which is a bounded amount of work with a predictable cost. That is why the ordering problem is tractable at all. The architecture reduced 1 billion posts to a few hundred before the ranking ever ran. And because the prepared feeds are derived data rather than the source of truth, you can throw them away. If the ranking changes or a bug corrupts a batch of them, you rebuild from the posts. Anything you cannot rebuild has quietly become a second source of truth, which is the one thing this design must not have. Separating the model you write from the models you read has a name, and it applies far beyond feeds. The Event Sourcing and CQRS series covers projections, how to rebuild a read model without downtime, and the consistency questions that appear the moment the two sides can disagree. That is where to go next.